Welcome back to Instance Level Settings. Going back to the Advanced tab, we can see a large number of settings. The first one listed is the Contain Databases setting. If this setting is set to true, which it is on this particular instance, then we can host contained databases on the instance. This setting is disabled by default and has to be enabled by an administrator. The File Stream settings, in this case, have File Stream as disabled. We can enable it here. If we need to change the network share name, we do that through the SQL Server Configuration Manager. In the Miscellaneous section, we have various settings that don't really fall into any specific group. The first one there is allow triggers to fire other triggers. If we have this setting enabled, triggers can be nested. In which case, if a table is modified and there's a trigger on that table, and that trigger modifies another table, and that other table has a trigger, then that other table's trigger would also be fired. You can end up in nesting loops with triggers firing in a never-ending loop, although SQL Server will only allow you to go about 32 levels deep with the nesting triggers, at which point it'll stop the next trigger from running. This is a safety net to make sure that you don't update a table and then have a trigger update the same table and just end up in a never-ending loop and never completing the transaction. The next setting is the blocked process threshold. This specifies the number of settings between blocked process reports. This defaults to 0 and should only be changed if you're having performance problems due to blocking and you need help solving that through the blocked process report. The cursor threshold tells SQL Server the number of rows in a cursor set at which cursor key sets are generated asynchronously. We set this as -1 so that it isn't disabled. If we need to enable this, we can do so, although that will impact how cursors are done. Realistically, we don't want to be running cursors on our SQL Server databases, so hopefully this setting won't matter. The default full-text language tells the SQL Server which language the full-text database engine should be using by default. Code page 1033 is the US English language code page. The default language is the default language for the instance. When we create new users on the instance, they will be set to this language by default. In this case, it's English. The full-text upgrade option tells the SQL Server database engine what to do with databases that have full-text indexes in them. There's a couple of different options available, which we can select from the dropdown. We can import, we can rebuild, or we can reset. If we rebuild, it simply wipes the full-text index and rebuilds it from scratch. If it imports it, it takes the existing full-text index and converts it to the new format. If it resets it, it simply wipes out the full-text index. The default is to import, and that usually works fine in most cases. The max text replication size tells the SQL Server database engine how large replication commands can be. 65,535 is the default. Optimized for ad hoc workloads tells SQL Server to only store stubs of execution plans on the first time that a plan is used. The second time the plan is used, it will store the full execution plan in cache. For servers that have lots of dynamic SQL, this is a good setting to enable. For servers that don't have lots of dynamic SQL, there's no reason to enable it, although realistically there's no problem with turning it on. Realistically, it's probably safe to turn on all servers. Scan for startup procs tells the SQL Server database engine every time it starts up to scan the databases looking for stored procedures that have been marked as startup stored procedures. This should be left as off or false unless you absolutely need it. The 2-digit year cutoff is set for the year 2049. You can adjust this as necessary. Basically, what this does is if I enter in the year as something lower than 2049, or 47, for example, it would then assume that I mean the year 2047. The network packet size, again, we want to leave that by default unless we have some important reason for changing it, because it does require changing a lot of network settings as well. The parallelism options, these are things you're probably going to want to change on most SQL servers. Specifically the cost threshold for parallelism. So in this particular case, the cost threshold for parallelism is set at the default, which is 5. In reality, on an OLTP workload, we're going to want to increase this probably to somewhere around 40 to 50, and then adjust the number accordingly depending on what queries are still being parallelized and what the cost of those queries are. We can set the maximum number of locks, which is 0 by default. We can also set the max degree of parallelism. This tells SQL Server the maximum number of CPUs that any one query can use. The default is 0, and we really do want to change this on basically all of our servers. We want to set this setting to whatever the number of CPUs in a single NUMA node is. We can see that fairly easily by looking at the Processors tab on this same screen. The reason we want to do this is that will reduce the cross-NUMA memory calls by those processors. Cross-NUMA node memory calls take a lot of time to execute compared to local NUMA node memory calls. So because of that, if we set the max degree of parallelism to the size of a NUMA node, SQL Server knows that it's supposed to keep all those processes within a single NUMA node. The last option there is the permissions setting. We can set permissions at the instance level for specific logins for specific reasons. There's a large number of permissions available that you can scroll through. I'm not going to go through all of them independently. There are about 30 or 40 of them. These permissions can be used to do things like grant specific users the ability to fail over an always-on availability group, or to create a database, or to alter a database. High-level permissions which shouldn't be granted except for very serious, specific circumstances. Let's go ahead and look at the settings that are available within the SQL Server Configuration Manager. The first one is FileStream. Now, we saw FileStream before in the SQL Server Management Studio settings in an earlier video. We see it here again because there are options available to set within the Configuration Manager. Specifically, we're going to set the network share name for the configuration of the FileStream subsystem of SQL Server. We can set the startup parameters of the SQL Server engine as well. SQL Server doesn't keep all its settings in the master database, only most of them. Things that it needs to know before the database can be started, like where the master database is, are found within the SQL Server Configuration Manager, which stores them in the registry. This controls things like the error log and the path to the master database files. This also gives us the ability to add in additional trace flags should we need to add additional trace flags in to get different configurations of the database engine available to us. We can also set the always-on availability group setting within the SQL Server Configuration Manager. This is just a checkbox that allows us to enable or disable the always-on availability group. Let's go ahead and take a look at the SQL Server Configuration Manager settings. So here we can see the SQL Server Configuration Manager. Now this has a variety of settings available within it, but we're only concerned with the instance level settings right now. To find those settings, we click on the SQL Server Services, and we see the list of available services on the machine. So in this case, we're just going to go ahead and double-click on the SQL Server service and get the various settings that are available to us. The first page that comes up is the login page. Now, this is the exact same information we would see in the Services control panel. Specifically, it says what account is going to be used to run the SQL Server service. If we're going to change this account, we want to change it in here, because SQL Server Configuration Manager is going to change some security settings on the Windows OS that aren't going to be changed correctly through the Services control panel. On the Service tab, we can see some basic information about the service. Because it's running, these fields are all filled out. If it wasn't running, things like the process ID would be blank. We can set the Start mode here on the Service tab as well. On the FileStream tab, we can enable FileStream for Transact SQL access and set the Windows share name. This is the exact same screen we would see when installing SQL Server, which we saw in a previous video. On the Always On High Availability tab, we see that there's simply an error message being displayed on this particular machine. That's because this machine is not a member of a Windows cluster and therefore cannot be used for Always On Availability groups. Were this machine available to be used as an Always On Availability group replica, there would be a checkbox we could check, which would enable always-on availability groups the next time we restarted the SQL Server instance. On the Startup Parameters tab, we can see the various parameters that are available. Right now, we've got the -D, -E, and -L parameter. The -D parameter, as you can see, is the path to the MDF file. The -E parameter is the path to the error log, and the -L parameter is the path to the transaction log file for the master database. These are the only databases that we have to reference because everything else is going to be referenced from within the master database. On the Advanced tab, we can see several read-only fields, as well as several changeable fields. We can see if the instance is clustered, if customer feedback reporting is enabled, and if it is, we can turn it off or turn it on, depending on our corporate requirements. We can see the default data path, we can see the dump directory, which we can change as necessary. We can disable error reporting, which reports back errors to either Microsoft or a corporate reporting server. We can then see a variety of other read-only metrics, such as the file version, the instance ID, the path within the registry, if this is a 64-bit operating system or not, the edition of SQL Server that we're running, as well as the version and the virtual server name if this was a clustered instance. In summary, there's dozens of instance-level settings that are available to us within SQL Server, both through Management Studio and through the SQL Server Configuration Manager. There's a wide variety of settings at the instance level, which can really impact the instance and the users running queries against the server, depending on how we set these settings. Don't forget, there are 2 different tools to use to configure these settings, and don't forget that you can only configure settings in one specific tool. The settings that are available within the Configuration Manager cannot be changed through Management Studio, and the settings in Management Studio cannot be changed through the Configuration Manager.